Hello, welcome to today's webinar. We're happy to have you here with us for this session, Planning and Design for Getting to Zero in Schools. I am Connie Umphris, Communications Manager here at New Buildings Institute. Before we begin, I have a couple of housekeeping things to tell you about. First, you are muted, we cannot hear you. This helps keep the background noise down so that everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. We will take a few questions at the end of the presentation. Please ask questions in the same question pane. Please take a moment to answer the survey at the end of the webinar. We consider your input in the planning of future sessions. If you are seeking AIA credits, this survey is where you will share your AIA number for credit submission. This session is being recorded. All registrants will receive an email tomorrow with links to the recording and slides for the session. If you need a certificate of attendance for your records, it will also be part of tomorrow's follow-up. I will now turn over control to my colleague, Riley Loveland, Project Manager here at NBI. Over to you.
Thanks, Connie. Good morning, good afternoon to some of you. As Connie said, I'm Riley Loveland and I am the schools lead over here at NBI. I spend the majority of my days diving into the nitty-gritties of transforming schools and the schools market to zero energy and carbon. So thank you and welcome to all of you. Thanks for joining. And for those of you tuning into an NBI webinar for the first time, NBI is a national nonprofit. We work to reduce energy and carbon emissions in new and existing buildings. We've been working in this schools market for many years and are thrilled to highlight the projects and the presenters today as they are just amazing leaders in the zero energy schools market. I wasn't even quite sure what word to use because they're so phenomenal. You won't hear much from me today because our presenters have great stories to tell, but in case you're enjoying the soothing sounds of my voice and would like to hear it a little bit more, please check out some of our other zero energy and carbon school webinars at this link. This is just a small list, there are more. And if you're looking to dive deeper into the resources available for those of you that are on the path or considering zero, please check out the schools section of the NBI Getting to Zero Resources Hub. The link is down here at the bottom. The Getting to Zero Hub has a bunch of different ways to sort and find specific information you're looking for. And there are 4 main categories for your path to zero: design and process, existing buildings, schools and districts, which is really the lessons learned from all of the schools and districts that have actually done zero energy and zero carbon, and then state and national resources. This is just an example of some things you can find on the hub. The one on, I believe it's your right, because it's my right, the Zero Energy Schools Stakeholder Engagement and Messaging Guide is my personal favorite. Here are the learning objectives for today. I won't read them, but if you need to refer back to them, they are here. As Connie mentioned, you'll get the slides after this presentation. So with that, I'm going to pass this off to our presenters. They can tell a much better, or do a much better job of introducing themselves than I ever could. So with that, Zachary, Brian, off to you.
Thank you, Riley. Yeah, real quick, my name is Zachary Schneider. I'm an electrical engineer with CMTA. I've been with the company for over 18 years now. I've worked on a wide variety of projects and numerous zero energy projects across the country. Brian, I'll let you say a quick word about yourself.
Thanks, Zach. Again, Brian Turner, CMTA Engineers, also an electrical engineer, and been around for 12 years. Zach, I didn't realize you'd been here for 18. Wow. I've had the good fortune over that 12-year period to work on a lot of our zero energy projects. So that's what excites me, and looking forward to talking about it today.
All right, great. Well, again, I'd like to thank everybody for your time. Look forward to any question that you have at the end. Hopefully we'll have some good dialogue. And the goal is after today's presentation, you'll all be able to take away some strategies on how to achieve a zero energy facility at no additional cost. So just kind of jump in, I'll give you a quick background on CMTA. We've been around for 50 years. We have experience across all sectors of the built environment. Roughly 20 years ago, we kind of started benchmarking our projects, and that's when we realized that we had some really efficient projects out there which kind of made us, look into it, study a little bit more, and realize that, zero energy is really achievable, which led us to our first zero energy building roughly 12 years ago. So this 20 years worth of data has given us a vast knowledge of how buildings perform, which gives us, ability to design better facilities. And so some of the pictures that you see in the background are just some examples of some of the zero energy projects, anywhere from schools to office buildings to a police station. Currently we have 15 offices. We're currently doing work across 48 states. We are, it says 385 employees. I think last count, we're actually over 402 employees. As you can see, numerous PEs, numerous LEED accredited professionals, and countless other designations, across our offices. To date, we're over 4 million square foot of zero energy design. We're creeping up on 5 million square foot. We've got over 120 projects that are zero energy capable, and we'll touch on those a little bit later. So we'll turn it over to Brian real quick to go through some things with you.
All right, I'm going to indulge in a quick motivational preamble here to remind us all why we care and why we do what we do. But I'm sure this picture is familiar to a lot of you out there. This is called the pale blue dot. In 1990, as the Voyager spacecraft was leaving the solar system, right on the edge of the solar system, Carl Sagan had NASA turn it around to take one last picture of Earth. And that's it there in the sunbeam. Didn't even take up an entire pixel. But that pale blue dot, again, it's all we've got right now. And not only that, there's a paper that came out last year by Anders Sandberg at the Future of Humanity Institute that speculates that of the 100 billion stars in the Milky Way galaxy, ours might be the only one that has intelligent life. So we've got a massive responsibility. But instead, we've been, conducting this insane experiment for the last 50 years to see how much carbon our oceans and atmosphere can absorb before disaster sets in. So, the secondary consequences of that are obviously air pollution, and maybe this picture is more appropriate right about now. Wildfires, drought, famine, extreme weather, and eventually climate change fueled global conflict. But in addition to all that, we've got a much more practical reason to be concerned, and that is that today schools spend more money on operations and energy in particular than anything, second only to salaries. And that's only going to keep getting worse because, as many of you know, energy costs typically outpace inflation while teacher salaries do not. So this is going to be a growing problem. But there's hope. There is a better way to do things. This is one of my favorite pictures. This is a Venus transit that was taken a couple of years ago. And, one thing that I think about is, in a few more years when we're able to take the same picture from Mars's orbit and take an Earth transit picture, it's going to look almost the same. We've got this practically limitless fusion reactor in the sky that we can take advantage of. And right now we're just not leveraging it. So there's a better way to do things and we need to change. However, that is definitely happening. There's no doubt that the grid is decarbonizing. Some of the authorities out there have made projections of how quickly that'll happen. And as you can see, a lot of them have done a terrible job of it. These are the past predictions of solar adoption by the EIA. And it looks like they're finally starting to catch on in some of the latest estimates, but I can promise you that the grid will decarbonize faster than almost anybody out there believes is possible right now. But in order to help facilitate that, we've got to do our job on the building side of things.
And one of the reasons, obviously the PV is getting more affordable. And so you look at this chart, this goes back to our first zero energy project to our most recent project about the overall cost of the solar and how that affects the overall percentage of the project budget. So in today's terms, today's dollars, we can typically do enough PV on a building to make it zero energy for less than 2% of the overall project budget. So you want to think about that on some of your projects. What do you spend 2% of that project budget on? A great example that we had was it was a large campus, had a lot of outdoor spaces and a lot of large sidewalks. we looked at it, did a cost study, and were able to reduce the sidewalk size to allow for enough money to be cost shifted from the cost of the sidewalk into the PV system to basically provide a zero energy building, again, at no additional project cost. We just cost shifted it from the concrete. Now, another great side effect of that, significantly reducing the concrete, significantly reduced the amount of embedded carbon that was in the project. So it was kind of a win-win situation. And so want to look at, a couple other, some reasons of if solar is now affordable, what are some other reasons that projects aren't zero energy more often? So we put this together as what we call, filters, things that have stopped a project from being zero energy. Not every project we start, has the potential to be zero energy, but a vast majority of them does. But so why is it such a small percentage of projects that actually make it there? Well, you've got these filters that you go through. The first one is the owner project requirements on RFQ. If you're an owner and you're wanting to do a zero energy project, get that into your RFQ early. Get that in writing so everybody that's responded to that RFQ knows you want this to be a zero energy project. The next thing that comes up is, when you get into cost estimating or VE, there's a lot of misconception that these zero energy projects are going to cost so much more. And so the first thing they VE out is, any of the items that are going to make it achieve that zero energy project. The next thing is construction. If things don't happen correctly in construction, the building envelope is a great example of that. We'll touch on a little bit later about, working with the architect, working with the team to be sure we have a good tight building envelope. But if that envelope does not get constructed that way and the building leaks, there goes one of your options of going zero energy. And then last one is building operations. If the building is designed to be, a 8-hour, 10-hour a day building, and then it goes into night setback, but yet that building is operating 24 hours a day, you're not going to achieve your zero energy goals. And so this just shows some of our projects that we've worked on that, we say are zero energy capable. Basically, they're efficient enough to where the PV would be affordable to make them zero energy. But the orange ones are the only projects that are actually operating as zero energy. Well, why is that? Well, it's because one of those filters that we just kind of touched on, something happened in those filters that filtered these projects out to be zero energy.
So this is a graphic that I think tells a fun, well, maybe not fun, but an interesting story. And when you look at the food chain of the AE industry and who makes decisions, as building engineers and designers, we find ourselves toward the bottom. There's a lot of areas in the country where there's strong policy and regulations that can help incentivize owners to make great decisions, but ultimately, we are empowered by our owners. And if our owner's not asking us for what we can offer, and they're not asking for a zero energy or zero energy ready building, then there's no shot of it happening. And I think one trend that we have seen on almost all of our projects is, a champion on the owner side of the table. It's not just enough for a school district to, have a policy or a carbon neutrality goal by 2050. If there's not an owner advocate that shows up to the design meetings and that speaks up and tells the rest of the team, here's what's really important. I understand this might, not be your first choice in some ways, but in order to reach the zero energy goal, here's what has to be done. And again, we've seen this time and time again.
Yeah, so when we look at the zero energy project, we kind of break it down into these 3 parts that we're going to touch on. Things that you must do to be zero energy, things that you should do, and then things that you could do. Now, all of these are important, but the must do items is kind of what we'll touch on first. So, honestly, any building can be zero energy, but only if you can afford the amount of PV to offset the energy use that building has. So obviously, I don't know about you, but I typically don't work on projects that don't have a budget. Very, very rarely you get a project with an unlimited budget. So how do you keep a project within budget, but still be able to do the zero energy? So this kind of shows you a good example of what it would cost to make a building zero energy. Now, this is a real world project. This is actually Discovery Elementary for Arlington Public Schools. And now keep in mind, this was a number of years ago, this was 2012. So what we looked at is if we would have designed Discovery Elementary to the ASHRAE bare minimum, the ASHRAE baseline, it would have cost $5.2 million to make that zero energy school, make that school zero energy. You equate that to the average school in California, for example, it would have cost $3.4 million. Well, what we were able to do with the actual EUI of Discovery at the time, it cost $1.1 million to make that school zero energy. Now, keep in mind, 2012, solar was over $3 a watt. At today's cost, well under $2 a watt, these numbers are drastically lower than what they would be back then. So the first step in figuring out how you make the building more efficient is you have to know where your energy goes so you know where to focus your efforts. So as you can see on this pie chart, HVAC is the biggest energy hog we have. So you kind of want to, that's the first thing we focus on. But then as you reduce that HVAC number down, then the other slices of the pie become more prevalent. So then that's the next thing you have to focus on. And so Brian's going to kind of jump into some of the HVAC strategies.
Yeah, we with so many zero energy buildings in the books right now, we see similarities across all of them. There are certain things that almost all of our projects are doing. So to me, these are the at least 4 of the staples, maybe the top 4 staples of any zero energy school. Everybody's using LED lighting today. There are better and worse LED lighting designs, but generally we're using a lot less energy for lighting than we did 10 years ago. But if you're not focusing on the building envelope, then you definitely need to be. And that's something that we see time and time again, not just thermal performance, but infiltration. But I would also caution, we're always looking to optimize, all of our systems, but especially the building envelope. We're looking for sweet spots. As soon as we start to experience diminishing returns, we know we're probably beginning to waste money, but even more than that, carbon as well. The embodied carbon associated with insulation is significant. So you can find yourself in a situation quickly where adding additional insulation is not the right move from a carbon perspective. How we deal with ventilation air is critical. Almost all of our projects feature a dedicated outdoor air system with energy recovery wheel and demand control ventilation. That allows us to actually bring more fresh air into the building, but we do it to only the spaces that need it. In general, heating and cooling, most of our zero energy projects have a distributed water source heat pump system. And the thing about a heat pump system that's using a neutral water temperature loop, you get free heat recovery. It's inherent. As you reject heat into the loop in one space, another space that might need that heat, that's for instance at the perimeter of the building, is able to pull it back out of the loop and use it to heat the space very efficiently. So a more traditional approach might be with a VAV system, you're going to cool a space. Well, you've got to cool it even beyond the 55 degrees that you're probably going to serve the space at, and then you got to heat it back up with reheat. It's kind of like driving down the road with a foot on the gas pedal and on the brake pedal at the same time. It makes no sense. Dehumidification, especially here on the East Coast, it's a big deal. And again, some of the standard methods for dehumidification heavily rely on reheat. And what we find is that the energy recovery ventilator in the DOAS unit is able to address the majority of that dehumidification and that latent energy. And then the heat pumps throughout the space, which are typically 2-stage or variable speed compressors, are able to address any of the remaining latent energy without actually adding energy consumption. Oh, sorry. Well, trying to get back to it. So kitchens, again, not all schools have kitchens, but most of them do. This is a critical space that typically is going to use about 250 EUI. You can't just focus on everything else in the building and ignore the kitchen, but it can be very challenging as well. We find that kitchens and IT loads in general can be 2 of the most difficult buckets to tackle because we don't have complete design control over them. We have to work with others. We have to get a lot of buy-in and agreement. And, we've learned over the years, I can tell you that if we're proposing an impractical solution, that's going to make it harder for the food service workers to do their job, or even worse, to require an extra food service worker in the kitchen, it's a deal killer. Another thing that I would caution that we've learned is knowing the percentage of free and reduced lunch for the students of the school, and understanding those demographics is critical to knowing how much the kitchen is going to be operated. What we find is that schools that have a very low percentage of free and reduced lunch, a lot of those kids just bring their own lunch and they brown bag it. And that means that you're not going to see a lot of kitchen usage. But if you're in a more underprivileged area and there's a high percentage, you're going to see a lot of usage. And that's something that we have to factor into the energy models. And it's something that we ultimately have to size the photovoltaic system for. So, you know, obviously pandemic resilience is something that's on all of our minds these days. And, you know, it's something that we have to address. Now, granted, in the hierarchy of things, we're only a small part of the solution, but there definitely are things that we can do. And what we're finding is the high performance buildings with a focus on health and wellness that we've been designing for the last decade are very well positioned to respond to pandemics. But, you know, there are additional measures that we can employ. So, you know, dilution with increased outdoor air. A lot of our projects have 30% increased outdoor air, you know, initially for improved air quality and reduced CO2 levels. But obviously this is one measure against pandemic. Filtration is one of the most promising things. I'm excited to see that a higher level of filtration is quickly becoming standard. And, you know, it's one that seems to have a small energy impact. And then, you know, additional measures like UVC and the ductwork and the air handlers, heat pumps, as well as bipolar ionization are promising technologies that we have been using but are increasing somewhat. So about 6 months ago, we did a quick study looking at what were the energy impacts of the initial ASHRAE recommendations that were released due to coronavirus. And what we did is we took the reconciled energy model of Discovery Elementary School and, you know, implemented these changes to see what the resulting energy usage would be. And it was about 50% extra. You know, a lot of these measures are somewhat crude, and I think some of them have been rolled back somewhat, but you can see that there's probably not room on the roof of Discovery Elementary for another 50% of PV. So we've really been focusing on, you know, which of these measures make sense and how can we implement them in a way that incurs a small energy penalty while, you know, while still yielding the vast majority of the benefit. So we're going to focus on the should do's right now, and you know, love them or hate them, to paraphrase Elon Musk, you know, doing something once is easy, but doing it at scale is difficult, and I think that's the challenge before us. You know, it's great to do zero energy projects here and there where we can, but you know, we need solutions on a much larger scale. So Zach's going to talk about how we do that.
Yeah, thank you. So one of the things that I've touched on a couple times and Brian touched on is we mentioned cost shifting, taking money from one place in the building, put it into another place in the building so it's not costing you extra. The building envelope is a great example of how we can do that, because whenever you have a good building envelope, it allows you to right size the HVAC system. As engineers, you know, we get accused, and I'll admit we used to be guilty of over designing some things. But if we know the envelope, we know how the building is going to perform, we don't have to oversize the HVAC system. And I've got a good example of that here coming up. Another thing is the lighting design and lighting control design. If you design the light for the space and you don't just blanket the ceiling with troffers, you actually go in and do calculations for every area, we found that you can greatly reduce the lighting and get a very low watts per square foot lighting, especially with LEDs of today. And then in conjunction with that, you have your lighting control systems. You know, 10, 12 years ago, I was guilty of designing the most complex, you know, latest and greatest lighting control system on the market. Well, with today's low watts per square foot, you just can't justify the payback for doing that anymore. So take the cost that you would have spent on your lighting systems, simplify them down, cost shift that to somewhere else. And then as you're downsizing your HVAC system, you're downsizing your lighting system, you're doing reduced plug loads, all of that affects your overall electrical distribution, which makes it a smaller switchgear, makes it less panels throughout the building. All that equates to less copper being pulled out the building. So again, you're saving costs to be able to use that money more wisely elsewhere. Glazing choice is another great example. We had another project where, again, shame on us, we were pushing with the architect trying to get the best, most expensive glazing because we thought that's what we needed to make this building zero energy. Well, we started to look at it and realized, well, actually, we can go with a slightly less expensive glazing, doesn't perform quite as well, but we did an energy model and determined how much additional PV we would have to buy to offset that energy, and the money that we saved from going to a less expensive glazing was able to pay for additional PV and gave us money left over that we could put into other portions of the building. So I mentioned the right sizing the HVAC systems. We've actually brought in a nationwide construction manager and had to do some cost studies for us, because we were confident the better envelope with the smaller HVAC system, proved to be a less costly option, but we didn't have any metrics to really prove that. So what we did, we worked with this large contractor, and we modeled the building, and they priced the building based on multiple construction types, typical ASHRAE baseline construction type versus CMU types versus precast walls versus ICF construction. They put a cost to the envelope of building each of those types. We then modeled each of those envelopes based on the infiltration that we, from our experience, the infiltration we know we can achieve with each of those types, and then design the HVAC system accordingly. That contractor then priced our HVAC system. And lo and behold, what it found out was the better envelope, which was ICF walls with, R20 roof and better quality windows, with the reduced HVAC tonnage we were able to achieve, was the first cost, least expensive option. That didn't take into account the reduced electrical load, the reduced lighting load, and didn't take into account the 30-year savings they were going to achieve, across the life of this building. But it just kind of nailed home that fact that first cost savings can be achieved by doing a high performance facility. And then in doing, looking at the envelope, this is an example of actually the current ASHRAE headquarters in Atlanta. We actually did a study of the building prior to the renovation that just completed. And we went in, pressure tested the building, and did some thermal imaging just to see how, how leaky the building was. And so these are just some great images that just kind of show, the glass storefront, how, how much it leaks, how poor of a wall system that is. We found some areas in the corners of the building that leaked, pretty severely, that you can see from the thermal cameras. We also have a fun tool that we brought on this project. We have a drone with a thermal image camera on it too, that we can fly around the outside of the building, see the upper corner, see the roof, can kind of get in some of the nooks and crannies that you can't get just by normal walking around. But, these are some of the things that you have to do to really be able to understand how good of an envelope you have, on your facility. And then, I've touched on these good envelopes. So how do you know you have the good envelope? Well, you know that by pressure testing your building. You include pressure testing in the front end specs. It is a very minor cost that will pay for itself almost instantly. And then if you have it in the front end, you work with the architect, you be sure the building is designed as, to meet these requirements. You put it in your specs, and then the contractors, as they're designing this building, as they're constructing this building, they're going to pay more attention to those details, because they know at the end of it, this building is going to be pressure tested, and they want to make sure it passes, because they don't want to have to go back and, rip out drywall, heaven forbid, or, go through the, find all the leaks of a building once it's almost finished.
So this is a great example of a zero energy project that we did in Florida. This was Neo City Academy in Kissimmee, Florida, with Osceola School District, and it was the first zero energy school in Florida. It pressure tested out to a 0.27 CFM per square foot. And, most of the credit here goes to the architect that we worked with, Philip Donovan with Little Diversified, did an amazing job of designing the building in a way that, we were very nervous coming into this, because we knew infiltration was going to play a large role in the energy consumption of this building. But we also knew that we were likely to get a tilt-up concrete construction, which is common in the area. There's lots of cracks and crevices. There's lots of ways for air to get in and out. And, he really took a low-cost belt and suspenders approach that, ensured that the building was sealed up tight. And another thing that we had was a mock-up on site that was pressure tested once it was complete. And, that first pressure test, it leaked like a sieve. And we found out that the air barrier had been penetrated, hundreds of times by fasteners from the cladding. Had that not been caught, it would have been done tens of thousands of times on the entire building. And we were able to get that corrected. And, in the end, the results speak for themselves. That's, exceeds passive house standards. Uh-oh.
Yeah, Riley, looks like we just jumped out of the presentation
Yeah,
somehow.
we got another presentation. Thank you.
Thank you.
Okay, lighting. I'm not going to dwell on this for very long, but in general, any zero energy school should be hitting less than 0.4 watts per square foot for the lighting power density. We've got a couple of schools that have gone under 0.3 watts per square foot, but anything over that and you're really wasting energy. Beyond that, the only thing I'll say, if I could caution one thing from an affordability perspective, do not let the lighting salesman design the lights. He sells lights for a living. He will ensure that you spend twice as much as you need to, and you will have fixtures, they will be denser than a neutron star. It will, easily cost $5 per square foot more than it otherwise would if you, took a thoughtful approach and really optimized the layouts. So again, on the should do's, absolutely, we should make every building a healthy building, whether you're pursuing a well building certified or not. Sometimes some of these measures are not conducive to zero energy, but they're important and they should be done anyway. So, on the topic of daylighting, I won't spend a lot of time here, but daylighting is critical to circadian health. We've known that intuitively for hundreds of years. But about 15 years ago, we discovered a new light-sensitive cell in the eye, the retinal ganglion cell, and this essentially has a direct pipeline to the part of the brain that is responsible for circadian rhythm. You want blue light content before 6 p.m. roughly. You don't want it afterwards. Daylight is critical to this, but then also choosing correct color temperatures in your spaces. In general, we recommend a 4,000 Kelvin LED for schools and offices and places like that where you're really trying to stimulate and you want high energy. So daylighting has also come a long way, the science of daylighting, I should say, in the last several years. Instead of just doing static calculations like we used to do for LEED to determine, well, how well daylit is a building, we can now do hourly simulations with spatial daylight autonomy simulations and glare analysis. So, generally we're looking, we want great learning spaces. We want them to be zero energy, but we always tell our architects, use as much glass as you need to. Obviously we want it to be used intelligently and judiciously. But what we often find is that you can end up with a building that has great daylight, for less than 30% window to wall ratio. But if it takes 40, that's fine. We've got the most efficient HVAC systems possible. We'll deal with it. We want a great space to be in. And again, regardless of whether it's a school or a more residential setting or a hospital or an office, we're really trying to pump that blue light during the day and move to those warmer color temperatures, potentially from lower sources, during the night. And again, this kind of appeals to the reptilian part of your brain and is conducive to circadian health.
Another item on health and wellness, CO2 levels and human cognition. Decades ago, NASA started to realize how important reducing the CO2 levels were. They were doing studies and they realized that as CO2 levels increased, the performance reduced. And so NASA's known this for years. Why wouldn't you incorporate this into any design that you do today? You spend so many hours in these buildings indoors, so why wouldn't you be cognitive of the fact of the higher CO2 levels, how it affects performance? And so everybody's probably familiar with this, but it's the Cog effect study. We looked a little bit deeper into it to kind of compare first cost and energy cost, based on effects of CO2. And so what we realized is it's not nearly a linear effect. To get the parts per million down in the 500 level, the first cost and the energy cost drastically increases for very little return on your investment. Basically, there's very little change in effect once you get down to those numbers. So what we found, a good realistic level that is realistic in first cost, energy cost, and where you kind of get the best bang for your buck is around that 800 to 900 parts per million. So that's really where we try to want to focus and want to get all of our facilities down to. So we kind of went through the must do, the should do. So now I'm going to touch on some things that you could do. Still very important to zero energy building. But one of them is, we were looking for a way to get everybody excited about working in a zero energy building. And so what we did is we created a dashboard. We call this dashboard Sphere. And so I'm just going to take a few minutes and kind of do a live demo. So thank you, Riley, for pulling this up. But what it is, it's an energy dashboard, but it's more than that. It goes deeper into the building. For a school building, we really wanted it to be a teaching tool. The last thing we want is to give the teachers more work. We want to give them a tool that helped their job. So as we started to develop these and design these, we sat down with the staff and asked teachers, what would you do in a classroom? How would you use this information? And so we got great information from them. So what you see here is, basically it's graphing the current energy use. And so this is actually showing net energy real time, exactly today as we speak, shows you the current building demand and shows you how the building's performing. So this is backed up, a week ago, and it shows you how much energy was used versus how much energy was produced to prove that this was a zero energy project. You can break that down into different loads. You can look at it on receptacle loads. You can look at it on mechanical system, but the teacher is able to pull this information into the classroom. And then they asked about, well, how can we utilize this information? How can we get this into Excel spreadsheets? So, they came up with these ideas and then we implemented them to where you can download this information as Excel, as PDF. They wanted the ability to draw on it. So as they were given a lesson, they could annotate on it. So we added, well, the teacher wants to say, well, why was the energy use here on this day, but then why was it up here at earlier in the day? Things of that nature, to where the teachers just gave us some great insight on how they could use this dashboard, in their school. So then another cool function that we was able to put into it, we went in and was able to take 3D pictures of the facility. And now these are fully 3D that can be moved around. If you have an iPad, if you have VR goggles, the students can utilize this. They can look up, they can look down, and I apologize, there's a delay on here, so I'm going to try not to make everybody sick. But you can go through, each room of the building. You can go to classrooms. We also added a function to where we was able to go through and take 3D images of the school while it was in construction, to where the students could walk up, click on this link that we called Window to the Past, and now they can see what the school was like under construction. Well, one of the teachers said, well, that's kind of like an X-ray vision. So some of it we call X-ray vision, where the students can now look through the ceilings, look through the walls to see the ductwork, see the conduit. The last thing I want to touch on is, the mechanical room. It's not realistic to bring, whether it's a school building, an office building, whatever, it's not realistic to bring people through the mechanical room at all times. So this gives you a 3D view into the mechanical room. And then throughout the whole building, we have these Easter eggs kind of hidden around to where you can click on it and it brings up information about the building. This brings up information about heat pump technology. We can bring up information about, the geothermal well field and how it's operating and what is a geothermal well field and how does the heat exchange work. But it's just a great tool that gets people excited about being in a zero energy building. And then students, they can take it home and show it to their parents, and then their parents can get excited about it. But anyway, just a great tool that we've used to really, drive home how excited everybody can be about being in one of these facilities. And then Riley, if you don't mind, we'll jump back into the PowerPoint.
Somehow we went to the wrong slide. Stand by, everyone.
No problem. Thank you. And this is kind of a first for everybody, so don't worry about it.
Let me see if I can do this a little quicker.
Yeah, we were on 50, the sustainability slide.
Thank you. All right, good to go.
All right, thank you so much. So anyway, just one more thing that we like to put in the should do category. You know, again, ways to get people excited to tie in the curriculum, to use the building as a teaching tool. So, you know, this is an example of, you know, created a solar lab on the roof. So you see here, students are able to adjust these panels and adjust them to different angles throughout the day, throughout the year, and then they can monitor and record how much electricity that panel is producing to teach students the effects of sun angle. And, you know, daylight hours. I mean, just great tools that you use to get students and occupants of the building excited about the buildings that they are in.
So while we're on the could do's, one of my favorite topics, microgrids. We have implemented battery energy storage systems into a couple of recent projects that were zero energy. And, you know, what we find is there's a lot of synergies when you've got a large photovoltaic system on the roof. You know, it's a shame, and a lot of people don't understand this, but if the power goes out, those PV panels turn off. The inverters have an anti-islanding requirement. So, however, with a battery storage system and just a little bit of islanding controls, what you can do is actually form a microgrid and island the building from the utility grid. And the PV inverters can turn back on and the building operates essentially as long as the sun's shining and as long as the battery lasts. So on a zero energy building during the summertime, you know, that's quite a while. But and what we did on both these projects is we were able to cost shift money away from what would have been a natural gas or diesel generator into a battery energy storage system. So it didn't pay for all of it, but paid for most of it. And then with the difference, we use these energy storage systems during normal power operations to reduce utility bills, participate in third-party aggregate energy services programs. And another thing that we're doing is actually using the energy storage systems to actively reduce marginal emissions and reduce carbon in that way. And what we do is basically we're going to charge the batteries during the cleanest times of the day when there's a lot of solar available on the grid and discharge them later as the sun's going down and all the natural gas peaker plants, the dirty ones, are turning on. And in that way, we can, you know, even further reduce the carbon footprint of the building. So moving on to some creative ways that we've used to fund photovoltaic systems for zero energy projects. You know, there's the traditional way, which is, you know, owner purchase. A lot of our owners don't pay taxes, so they're not eligible for the tax incentives that are available. That doesn't mean that it's always not the right decision. It absolutely is in some cases, but there are some other creative ways to fund these systems potentially. One's through a power purchase agreement, and you know, essentially you've got a third party that comes in and at no cost to the owner will provide a photovoltaic system on the roof, and then we'll sell the energy from that system to the school district. And you know, this is again a great way to get a zero energy building at no additional cost. This is the new model for Arlington Public Schools, who we've done several zero energy buildings for just outside DC. A third way is guaranteed energy services contract, and you know, essentially you're using the future savings of that PV system to pay for the PV system today. And you know, there are ways to do that we'll get into in just a bit. At Arlington Public Schools, Fleet Elementary was the next building, zero energy school that we did after Discovery Elementary opened in 2015. Fleet's been open for just over a year now and is officially zero energy. It operated about a 17 EUI as well. And what they did is they wrapped that building into a larger power purchase agreement that spanned district wide. So they bought 2.5 megawatts of, or the contract covered 2.5 megawatts of PV total, and about 600 of that went onto the roof at Fleet to make that building zero energy.
Yeah, and the third option, oh, sorry, let me back up. The third option that we touched on was, you know, the guaranteed energy savings contract. So this is a good case study that we was able to work on for Warren County Public Schools. And just a side note, Warren County Public Schools is where Richardsville Elementary was, which was that first zero energy, you know, elementary school roughly 12 years ago. But we went in and benchmarked all of the facilities in the district, got an average EUI at the time, which was 40.7. Then we went in with our guaranteed energy savings contract, did work at all the facilities, and was able to get their average EUI, you know, not quite in half, but was able to cut it down to 26.8. Well, we were able to take the savings, energy savings from that, and fund the solar panels for numerous buildings throughout the district. And then we ended up taking a lot of that, PV and adding it to a new facility that was being built, which basically created a zero energy facility at no additional cost to the owner. It was all based on the guaranteed energy savings from the projects that had been done.
So we've covered a lot of ground, I think, so far, and one might be asking at this point, where's the proof? And we think we've got a compelling case study. Again, in Arlington Public Schools, just outside of DC. This is roughly all of the major school projects that they've done over the last 8 years since we've started working with them. And the green projects down at the bottom, which are, generally less than half the EUI of the others, are the zero energy projects that we've worked on. And, this idea that a zero energy or zero energy ready project has to cost more is just not true. It's all about priorities. The size of the dot on this graph corresponds to cost per student station. And as you can see, the zero energy projects are equal to or even less than the other projects that were done in the district that were not zero energy. So what's next? Well, we've been doing zero energy projects for, again, over a decade, but we've just scratched the surface. There are so many other things to figure out. There are so many better ways that we can improve design. There's building electrification, there's a focus on embodied carbon. There's the fact that the zero energy buildings that we've been designing for over a decade are not great for the utility grid. They kind of wreak havoc on it. And, we've got to improve grid harmonization and how our buildings interact with the utility grid to enable, further solar and wind adoption in the future. But on the electrification front, this was a study we did last year working with Sidwell Friends School in DC, where we studied a ground source heat pump system versus a more traditional fan coil system that uses chilled water and a natural gas boiler. And you can see there's a large difference in the carbon footprint day one, but as the utility grid decarbonizes over time, there's a huge difference over 30 years. Essentially our all electric ground source heat pump building levels off and approaches zero carbon emissions over time, whereas the building that's using the natural gas boilers just increases. So another thing that we think a lot about is refrigerant management. Project Drawdown, which I'm sure many of you are familiar with a few years ago. I think there are some revised recommendations, but at the time, the #1 recommendation for reducing carbon emissions was better refrigerant management. We need better refrigerants that have, lower global warming potential, but there's also, a massive difference between some HVAC systems. Some HVAC systems have, essentially a direct linear relationship between square footage and the volume of refrigerant needed. And in general, we try to avoid those systems.
And yeah, it's more on the embodied carbon. A typical building, most of the carbon was from operational energy, and a small piece of the pie was from embodied carbon. Well, if you now take that same information and you apply it to one of our high performance or zero energy facilities, the operational energy carbon becomes much less because of the reduced energy use, but that embodied carbon is still the same. It was still the same construction type to build that facility. So we're actively looking at ways of trying to reduce that embodied carbon. And so give credit of Michelle Ant of VMDO Architects for a study that they worked on to look at embodied carbon and carbon usage for 2 of the facilities we worked on with them. One was Fleet Elementary, one was Lover Run Elementary. As you can see, the great improvement in carbon reduction and emissions, but we still have a lot of work to do on embodied carbon. And one of the side notes on one of these projects, Fleet Elementary, was on a really tight site, so much so that there wasn't enough parking on the site. So we actually had to do 2 levels of underground parking, which all concrete underground parking structure obviously added lots of embodied carbon into that project. So we we're working on it. We're looking at it. That's the next, the next wave of, how are we going to get the embodied carbon down to more acceptable levels on some of these projects. Sorry, let me jump ahead. Here we go. So another fun study that we was able to work on was looking at Discovery Elementary. That, as we've already talked on, this was a zero energy school, but we wanted to see how much additional PV it would require to make it a carbon neutral school. And what we found is if you took all of the embodied carbon and electrified the school buses and were charged from this location, that it would require almost 4 times the PV that we currently had on that project to make it truly carbon neutral. As you can see with that roof, we're not going to be able to squeeze 4 times the PV on that roof. So again, like I said, we're making great strides, but we need to really push the envelope harder on embodied carbon.
So we've got some exciting new projects that we've been working on right now. One that I just want to spend a moment on is in Ann Arbor, Michigan, which gave us Earth Day. And, they've got some really strong local initiatives for carbon reduction. And we're working with Ann Arbor Public Schools. They basically need to replace all of their buildings over the next decade or so. The average age of their buildings right now is about 1953. So they've got a lot of work to do, but they've determined that they're going to do it, not just focusing on energy, and they really want to make good decisions based on life cycle carbon accounting. So we've been working with them on that, and it's fun. We've had a lot of fun working through that, and showing them what's possible and showing them what the impacts are of embodied carbon in particular, but also some of the other scope 3 emissions, and they are enacting a lot of change. And that's it, basically. We have a quick announcement on the way out, and we'll be doing a Q&A here in just a second, but we did want to announce that we are opening a new office, and we are coming to the West Coast. CMTA will be opening a California office in 2021 very soon. So if anybody is interested in working with us on projects or working for us, we're looking for excited and talented individuals. So please reach out. Thank you.
Thank you, guys. First of all, I'm real excited you're coming to the West Coast. For those I didn't mention, NBI is in Oregon, so we're right above you. We'll see you here on the West Coast real soon. Connie, do you want to ask some questions?
Sure. Would you guys like to turn on your cameras for this section? Excellent.
Hello, everyone.
All right. So we did have a couple questions. The hot topic right now is COVID and classrooms. So we have 2 questions that are directly related to kind of the future of schools in this day and age. Wondering your thoughts on using thermal mass exposed to the interior in school projects. The AEDG recommended mass walls with exterior insulation as being the most energy efficient in all climate zones. With COVID now a reality and experts recommending fresh air, seems like the energy storage capacity of exterior insulated mass could be helpful because of its ability to moderate indoor air temperatures. Your thoughts?
By the way, the AEDG, for anyone plugging in, is the Advanced Energy Design Guide from the National Renewable Energy Lab, and that's for zero energy schools.
I think that's a great comment. We are big fans of thermal mass. We have used ICF walls on a lot of our projects, and granted, there's that's not with exposed thermal mass on the inside, but you still get somewhat of that effect. So we do currently a lot of projects on the West Coast, particularly in climate zone 4A, and they're very challenging climates, but what we don't see a lot is that that large diurnal swing between night and daytime temperatures, where you really get the most benefit out of thermal mass. To your point, with pandemic measures, we're all buildings are probably going to start bringing in a little more outdoor air. And maybe that's something that we should be focusing on more. As we start doing more work in climates that are more appropriate for natural ventilation techniques, I think that's something that we personally are going to look at a lot closer.
Okay, so the next question is, many buildings are built with windows that cannot be open. Given the importance of having open windows in the reduction of spreading the virus, how can people be assured that coronavirus is being removed from the air inside, in any inside building, when the windows are not able to be opened?
I'll jump in quickly. So yes, agreed. A lot of the buildings we do do not have operable windows. We get fresh air in by using the dedicated outdoor air system that Brian touched on. So the good thing with the dedicated outdoor air system, you are bringing fresh air in, but it gives you the ability to condition that fresh air and filter that fresh air to where, we're kind of pre-treating it before we introduce it into the building. So you're getting the same benefits from the fresh air, but it's being pre-treated, which helps your energy. It's being filtered. Now, as far as, getting the virus out of the air, the HVAC system has ways to help mitigate it, but I don't want to lead anybody down the path and think the HVAC system is the solution to this problem. It's just one of many items that, kind of work hand in hand, to where, like I say, I just don't want to mislead anybody and say, yes, if you have enough filtration, you have all these products in, you're going to eliminate the virus in your facility. That's not the case. There hasn't been studies that have proved that, but it will help the facility by doing some of these things. But yes, we work in buildings all the time that don't have operable windows, which just makes that dedicated outdoor air system that much more important.
Yeah, one thing I'll point out, we're working on a project right now in downtown DC, and it's a zero energy community center, Stead Park Community Center, and we're pursuing a 30% increase of outdoor air over code for that project. But because we're employing demand control ventilation and that building's not always going to be full, what we're able to do is we're able to even further overventilate the areas that are occupied in that building. So on average, unless there's 300 people upstairs in the community meeting room, that building is able to achieve something like 300% airflow over code levels. So we will have some windows that open as well. I like to open windows, but I guess that's just not always the answer to get fresh air. There are other ways to do it.
And another great thing with these systems is we're starting to implement this now too, is doing a building flush. At the beginning of the day, the end of the day, wherever, basically you turn on the outdoor air system and just let it run, and just basically let it flush that building out. So come the next school day, next work day, they come in and the building's basically, all the air's been evacuated and brand new fresh air has been brought in.
Great. So just a little note on that. People are also thinking about, how does that dedicated air system, outdoor air system, work when you're dealing with the kind of wildfire smoke that the West Coast was suffering with and is suffering with? Any thoughts on that before we log off today?
Yeah, there are. So we will put an emergency shutdown, more or less is what it is, to where we do a lot of work in Houston, Texas, as you can see with one of our offices, a lot of chemical plants in that area. And so we will implement an emergency shutdown button, in that building, to where if there is pollutants, if there is chemicals, smoke from the wildfire, you do basically shut down that outdoor air. Not a great long-term solution because you want that outdoor air, but it will be a temporary solution if you have, something going on outside your building that you don't want pulled into your building.
Yeah, and obviously in California with the wildfires, it's sadly a little more predictable than some sort of chemical spill or something like that. But, I think filtration is the answer. And that is, again, one positive side effect of, the coronavirus is that we're seeing higher levels of filtration being used at DOAS units, but also, at zones on heat pumps. And, ultimately, what we're looking at is running some of those zones in fan only mode when it's not calling for heating and cooling, and it's essentially acting as an air purifier for the space. So, those filters are a little more expensive, but unfortunately, that's probably the answer for the near future.
Right, so it sounds like these buildings need dedicated outdoor air and the capability of recirculation in the building, which is something I've been considering in my home. So it's good to hear that. I think that's it. I was just looking at what time it is. Oh yeah, it's 11 o'clock on the dot here. So I'm going to close us out. Thank you both, Zachary and Brian. Thank you everyone for tuning in. We really appreciate all of you. Let us know if you have any questions. These guys are always around and are in contact. Have a great day.
Thank you.
Great. Thank you all. Appreciate your time.